Right, so igneous rocks, we've talked about how they form, where they form, what can cause magma to form, right? So why are igneous rocks different, right? If they're all formed from magma, why do they vary in composition? How do we have different types of igneous rocks? And that's because the composition of the melt itself, the composition of the magma itself can vary. Okay, so just like minerals, melts have variable silica contents. Okay? If a melt has a lot of silica, we call that felsic. If a magma has very little silica, we call that mafic. If it's in the between, about 50%, right, a little more than 50%, we call that intermediate. And just like minerals tend to be lighter in color when they're felsic, when they have lots of silica, rocks do as well, right? So rocks that have a lot of silica are going to have felsic minerals. We're going to call that rock felsic. It's going to be light in color. Rocks that don't have a lot of silica, they don't have a lot of silicate minerals, right? We're going to call those mafic, and they're going to be dark in color. So we know that melts do vary. One of the ways they vary is their silica content, how much silica is in them. But why do they vary, right? And they can vary for several reasons. One is that the source rock determines the initial melt composition, right? Whatever rock you start with, when you melt it, the melt is going to have that composition. All right, so for example, the rock I'm showing here is gabbro, it's mafic. So if it were to melt, it would produce a mafic melt. Now, two other reasons we're going to talk about that melts can vary are a little bit more complicated. Right, we're going to talk about partial melting and fractional crystallization and crystal settling. So partial melting. Partial melting occurs when only a portion of a solid is melted. Right, so for example, a rock is made up of many different minerals. So as that rock starts to melt, some of the minerals are going to melt before other minerals. Right? So silica has a relatively low melting temperature. That means the silicate minerals are going to melt first. The felsic minerals are going to melt first, leaving the more mafic minerals solid within the rock. And as the temperature increases and more and more and more of that rock melts, then the mafic minerals will also melt. But initially, the melt is going to start off as relatively felsic compared to the rock because the felsic minerals melt first. All right, that's partial melting. The second thing we're going to talk about is fractional crystallization and crystal settling. And this is kind of the opposite of melting, right? This is after the magma is liquid, the rock has already melted, but now the magma is cooling down and going back into a solid. It's going to go through fractional crystallization and crystal settling. So as magma cools, crystals settle out by gravity, right? The magma cools, crystals form as solids. Solids are denser than liquids, so they settle out to the bottom of the magma chamber. Okay. So for example, iron, magnesium, calcium, those are removed and settle out early, whereas silica, aluminum, sodium, those remain in the melt and increase in abundance relatively as those other elements solidify and settle out. Right? So in the beginning, the melt has all these different elements within it. Over time, some elements crystallize before others and settle out to the bottom of the melt, the bottom of the magma chamber, leaving the melt relatively abundant in those minerals that don't solidify as quickly. And we call this Bowen's reaction series. So Bowen's reaction series, it's really cool. And it explains the two things we just talked about, partial melting and fractional crystallization, right? This series, this chart shows us how different minerals melt at different temperatures and likewise form back into a solid, freeze back into a solid at those temperatures, right? So minerals that are mafic, right, low in silica, these are like olivine, pyroxene, plagioclase, those minerals melt at a really, really high temperature. So they're the last to melt, but they're also the first to crystallize. Right? So they're the last to melt when a rock is melting, but they're the first to crystallize when a melt is solidifying. Likewise, minerals that are felsic, like quartz, muscovite, potassium feldspar, those have a really low melting temperature. So they are the first to melt, but the last to crystallize. So Bowen's reaction series, it explains partial melting and fractional crystallization, right? Mafic minerals crystallize first, felsic minerals crystallize last. It also explains why we tend to see certain types of rocks together, right? If you see a mafic rock, it's probably going to be surrounded by other mafic rocks. If you see a silicate rock, it's probably going to be surrounded by other silicate rocks because the different compositions of rocks tend to form in different environments.